Example 2 for the factoring strategies is to solve limits. We got the limit as x approaches 3 of 9 minus x squared over x cubed minus 27. If we try direct substitution here, if we plug in 3 for x, we'll get 0 in the numerator, and we'll also get 0 in the denominator. It'll be an indeterminate form. So we'll have to factor this. Now notice how this denominator is it's a difference of cubes, and you may want to go over the sum and difference of cubes from advanced functions, because you're going to be using a lot of it, especially in the change of variable strategy. So make sure you're comfortable with factoring a difference of cubes. So let's factor that on the side actually. So we'll have x cubed minus 27. All right, and what's the general formula for a difference of cubes? It's a cubed minus b cubed, and it's equal to a minus b, a squared plus ab plus b squared. So in this case, our a is the third root of x cubed, which is just x. The third root of 27 is 3, so our b is equal to 3. And then we just plug in these numbers into the formula. So a minus b is x minus 3. A squared is x squared, plus ab is 3x. And then b squared is 3 squared, which is just 9. So x cubed minus 27 is equal to x minus 3 times x squared plus 3x plus 9. Now let's factor 9 minus x squared. That's just a, you know what, let's factor that while we're doing the limit actually. So we'll have the limit as x goes to 3. 9 minus x squared is what? It's a difference of cubes, right? So we'll have 3 minus x and 3 plus x all over x cubed minus 27 is equal to, we factored it there, x minus 3, and then x squared plus 3x plus 9. This bracket here in the difference of cubes, we can't factor it anymore. So we just leave it like that. Now what we can do is we can factor out a negative from this first bracket. Notice how we still can't plug in 3 because of this x minus 3 here. It will make the denominator 0, so the expression will be undefined. But if we factor out a negative from this first bracket in the numerator, we'll end up having negative 3 plus x, which is the same as x minus 3. We just switched the x and the 3. So if we factor out a negative, we're left with x minus 3 in the first bracket. The second bracket stays the same. All over, let's just rewrite the numerator as x minus 3. And then we'll have x squared plus 3x plus 9. And then notice how this x minus 3 cancels out. So we're just left with the limit as x approaches 3 of negative 3 plus x all over x squared plus 3x plus 9. This is after the x minus 3 brackets cancel out. And now we could plug in 3 into the expression for x, because the denominator won't be 0 anymore. So we'll have negative 3 plus 3 over 3 squared plus 3 times 3 plus 9. So here we'll have 3 plus 3 is 6, and then negative, so it'll be negative 6 over 3 squared plus 3 squared is 9, 3 times 3 is 9, so 9 plus 9 plus 9 is 27. And then negative 6 over 27, that just simplifies to negative 2 over 9. So the answer for this limit as x approaches 3 of 9 minus x squared over x cubed minus 27 is equal to negative 2 over 9. So pretty simple. The biggest thing is this difference of cubes. You may want to review that from advanced functions. We're really going to be using a lot of that in change of variable. So make sure you're comfortable with factoring a difference and a sum of cubes. So it's going to come up in strategy 4 for sure. It will also sometimes come up in factoring.